Can you hear me, students?
Yes.
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 Yeah.
Now my computer just turned off on me.
Yes.
Yes.
It turned off by itself. I don't know what happened. It froze and then it turned off. One moment. You see now?
Yes.
Okay, thank you.
We don't see you though.
You don't see me?
Nope.
Okay. You see me now?
Yeah.
Yes.
Okay. Okay, so we have the 6 benefits of the cloud computing. Trade capital expenses for variable expenses. So instead of investing heavily in data centers and servers before you know you're going to use them, you can pay only when you consume computing resources. I'm paid only for the amount you consume. That's what that means. Now, benefits for massive economies of scale. It means that what AWS does is when you use cloud computing, you can achieve a variable lower cost that you can get on your own, because usage from hundreds of thousands of customers is aggregated in the cloud. Providers such as Amazon Web Services can achieve higher economies of scale, which translates in lower pay-as-you-go costs. Now, this is not only for AWS, this is for all the cloud providers, but AWS can afford to have a massive economies of scale because they have millions and millions of customers, and the more customers they have, the more discounts they offer. AWS has decreased their prices 67 times since 2006. So that's a huge undertaking, and that what really makes me passionate about AWS, because it's very cheap and it's very effective. That's something that sometimes people don't consider when they are thinking about moving to the cloud. They're not thinking about the cost, how much money they're going to save, and they don't know that by themselves moving to the cloud, they are collaborating for a cheaper price, a cheaper cost of the cloud. Now, stop guessing capacity. What it means is that you don't have to think about how many servers I'm going to use at Christmas, or on Thanksgiving, or July 4th, if I have a lot of traffic. I don't have to think about what capacity I'm going to need when this happens. With the cloud, you can stop guessing capacity. And you can use services like automatic scaling and set up a policy that when a specific CPU gets to 80% or more, for example, you can tell auto scaling, please launch 2 more servers because I want to be able to cope with this particular demand that's happening now. Now, if the demand is low and I have more servers that I need, what happens is auto scaling will remove 1 or 2 servers depending on what you set up in auto scaling. So you don't have to guess about capacity anymore. It will automatically adjust to the demand that is taking place at the moment. So that's one of the huge benefits of the cloud. Now, increased speed and agility. This is just a click away. With the cloud, everything is a click away. You can reduce the time it takes to make those resources available to your developers, for example, in just minutes, not weeks. Sometimes it may take weeks, but with these benefits of the AWS cloud, you can have your resources up and running in a matter of minutes. And that's something really, really, really cool. And this, for example, the taking of the cloud benefits, it just results in a dramatic increase of agility in your organization because the cost and time that it takes to experiment and develop is significantly lower. So like I said, it takes minutes, not weeks like it usually takes when you're not in the cloud. Now you can stop spending money on running and maintaining data centers. Usually a data center in AWS has around 50 to 80,000 servers in a data center. So that's a lot of servers that we don't have to worry about. So how the infrastructure of AWS is structured, you have regions, then regions have 2 or more availability zones, and every availability zone has 1 or more data centers. And every data center has between 50,000 and 80,000 servers. So AWS has your back. You don't have to worry about any spending on running, or maintaining, or patching, or updating any server. It's all done by AWS or the cloud provider that you are working with. In this case, AWS. So you can go global in minutes. So you can easily deploy your app in multiple regions around the world with just a click. Okay, so right now, AWS has around, I think it's 84 availability zones and 24 regions in the entire world with 216 points of presence. And they have 24 regions. So in the whole world, you can access your resources if you create servers there in a matter of seconds. You don't have to go all the way from China to the United States to access a server, okay? So you can use the low latency benefits of the going global in the cloud, in AWS, and have your resources just in seconds. So that's a huge benefit of being in the AWS cloud. Now, in AWS Web Services, what do we have there? We have storage, development and management tools, content delivery, analytics, messaging, compute, app services, payments, networking, on-demand workforce, VPC, mobile, databases. You can see they have everything that we need, everything that we need. So AWS has been in the business for over 10 years, since 2006. Well, actually 14 years now, okay? More than 10 years, 14 years to be precise. Everything started in 2004 that Jeff Bezos and other colleagues that were talking and they just came up with the idea of renting their platform. How can we share our platform with other businesses and still make money with that. So they created Amazon Web Services in 2006. And since then, for 14 years, it has been #1 cloud provider in the world. And I'm talking about Goliath and David compared to the others. Even though Microsoft Services, it's a huge cloud provider, still AWS is much bigger than Microsoft. Even though Microsoft has been getting very good deals recently with the government, because unfortunately some people in the government don't like, especially the president, he doesn't like just Vestas. So he prefers to have some contracts with Microsoft. And of course, AWS loses money, but still, I mean, it's making a lot of money. Now, question for you: do you know what company was the first company to go all in the cloud with AWS? Do you have an idea? And I don't want my students in the morning to answer because they know the answer. Do you have an idea what was the first company that went all in the cloud with AWS? No answer? So anyone can answer now?
Netflix.
Correct. Netflix was the first company to go all in the cloud. All the resources that Netflix has, all the data, everything is in AWS completely. And I saw that one of the students asked me a question about how much Netflix pays AWS every month. And one of the students, I think they posted like $9 million. I don't know. Someone posted in I don't think it's millions. I don't think it's millions, but they're making a lot of, I mean, they're paying AWS a lot of money because Netflix is a huge company, even though it's restricted in some countries. For example, in China, in Cuba, it's a little difficult to have Netflix because you don't have bandwidth for that. The internet is very slow, but Netflix is virtually in the entire world because they're using AWS, and AWS is global, is in the whole world. Okay, so I believe that if business owners knew more about AWS, I don't think they would doubt for a second to migrate to the cloud. Okay, so what's the stack? For example, here in Platform as a Service, Platform Services, we have databases, databases that are relational, for example, NoSQL. In this case, we're talking about, this is DynamoDB table, NoSQL, because we don't use structured query language, which is a language to query the databases. We have relational. In this case, we're talking about RDS, which is a relational database system. And caching, we're talking Elastic Cache, which is a service that you can use to cache all the information, the frequently accessed information in your database. Analytics, we can see here, we have some warehousing. In this warehousing, we have Redshift, which is a service that is for warehousing. We also have data workflows. In this case, we have something called step functions. Oh my God, sorry about that. This mouse is very sensitive. Cluster computing, we can have some, ECS, like Elastic Container Services for cluster computing. We can have some queuing services, SQS, simple queue service, we're gonna see that. Orchestration, step functions that work with different Lambda functions here. Upstreaming, we can have some Kinesis there. Transcoding, we can have the Elastic Transcoder service. Email, we can have SES, simple email service. Search, we can have some Elasticsearch for searching. Containers, we can have ECS, we can have ECR, which is Elastic Container Registry. to save some images for the containers. We can have some Docker containers. Here we can have in developer operation tools, we can have code deploy, code commit, code build, code pipeline. So we have all those services that are good for that. Resource templates, we can have CloudFormation and SAM for deploying services using code. We're gonna see some coding, how to create EC2 instances, how to create VPCs, how to create security groups with code, okay? Usage tracking, we can have some CloudTrail, which is a governance and compliance service to track the usage of different services. We can have some monitoring services like CloudWatch, which is a service that has some metrics to know the health, understand the health of your resources. And CloudWatch has logging. And also we have VPC flow logs. We have CloudTrail logs. Logging is very important for, compliance, just in case some auditors come to your company and they want to see some particular data or how you're complying with security, and then they can use the logs, and it could be good for that. So we have identity services for mobile. In this case, we have Cognito. We have federation services, users. We have AppSync, which is another application that I use to sync devices. We have mobile analytics. We have notification. In this case, we have SNS, simple notification services, that is used to notify subscribers or users of a particular usage of a service. In the foundation services, we have compute, networking, and storage. We have virtual, auto-scaling, and load balancing. Virtual, we have the servers, EC2s. Auto-scaling, this is the guy that helps us adjust to a demand. When the demand is high, auto-scaling will create more servers or increase servers when the demand is low. And load balancing is a traffic cop that distributes the traffic evenly to different EC2 instances. And of course, it has something like a heartbeat, like a health check, that is sent to the servers every time, every maybe 10 seconds, 1 minute or something, to check if the server is up and running, if it is healthy. If it is healthy, it will continue sending the traffic to that particular EC2 instance. If it is not healthy, it stops sending the traffic there and moves the traffic to a different instance when auto-scaling creates a new instance. When I say instance, I'm referring to an EC2 server, okay? When we create an EC2 server, we are creating an instance of that EC2 server. Networking, we have the VPC. We're gonna see VPC, Virtual Private Cloud, which is an isolated section of your network when you can have all the resources there, and there's a bunch of security involved in a VPC, like NACLs, which is a network access list, access control list. It's a NACL, known as NACL, NACL. We also have security groups for the EC2 instances. Think of that as a firewall in your computer. Then that's the EC2 security group. It's a firewall for your server. And then we have storage, where we can store the data that we have in our infrastructure. We have several services with object level storage. That's S3, which is simple storage service, S3, 3 S's. And then block, we have EBS, Elastic Block Store. And then we have, for archiving, something called Glacier, okay? Amazon Glacier, which is for archiving, Very important. When you need to archive, your objects. You just use Glacier, and that's going to be secure. Now for Glacier, encryption is mandatory. It's by default. Okay, all your data is going to be encrypted, secure in Glacier. Now in S3 is optional. You have to set it up. You have to encrypt it. You have to, enable the option that says encrypt the data. But with Glacier, it's by default. It is encrypted. Now in the infrastructure, we have regions. Like I said before, AWS infrastructure, global infrastructure is divided in regions, availability zones, and then edge locations. Edge locations are locations that CloudFront, which is a global service, uses for a better user experience. So you have a lot of regions, edge locations in different locations of the world. So what users do, they access the data, and automatically they are routed to the edge locations where the frequently accessed data is cached for you. Okay, this is similar to Elastic Cache, but in a global way. Elastic Cache is for a database, a particular database. Edge location is for the entire world. Okay, it's a global location. So now we have the AWS Foundation Services, the Platform Services. We have the AWS Management Console. I have a question for you guys. Did you create the free account with AWS?
Yes.
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 Yeah.
That's very important to become familiar with the AWS console. Why? Because in the test, you may have some questions related to how to access this, how to get there, what to do with this in the console. So it's very important that you become familiar with the AWS Management Console. Did you guys download the CLI?
Yes.
Yes.
Very important.
Yes. Yes.
Yes.
Yeah, very important. We're gonna see how we can create resources with the CLI. Okay. So here we have some services we saw. We talked about Amazon EC2 already, auto scaling, Amazon VPC, Amazon Route 53, which is a DNS service, Elastic Load Balancing, Amazon CloudFront, which is a global service for content delivery network. Amazon EBS is a block storage service. Amazon S3, that's an object storage service. Amazon AFS is a storage in the cloud, is mounted on the cloud, on the network, I'm sorry. Amazon Glacier is for archiving. Amazon CloudWatch for monitoring. AWS CloudTrail is for tracking the usage of everything. Everything that happens in the cloud, in your infrastructure, is gonna be recorded with CloudTrail. So you don't have to worry about who deleted this service or did this with this service, who accessed this data. It's gonna be in CloudTrail for sure. And AWS CloudFormation, also known as Infrastructure as a Code, IaaC, which is used to create services with code. Another question for you guys. Do you download VS Code?
Yes.
Yes.
Okay, VS Code is gonna be used in the class to create resources with code. Okay, using YAML. YAML is a notation language it's a key value notation language that we're gonna be using to create EC2s, VPCs, parameters, outputs, and all that using CloudFormation. Okay. So when you think about unmanaged and managed services, what comes to your mind? So unmanaged, I will answer the question too. It's something that you have to manage. is unmanaged, right? When I say unmanaged, it's unmanaged by AWS. AWS doesn't manage it. You manage it, right? So we have to know the difference between unmanaged services and managed services. When it's unmanaged, everything that has to do with that infrastructure or service has to be run by you. I'm talking about scaling, fault tolerance, availability, and all the benefits that come with the cloud. You have to create it, which is a pain in the neck because you have to be thinking about everything, security, be able to cope with the demand, being able to even run when your services fail. You have to be even able to continue offering your services even when your infrastructure fails. So that's a pain. So it's better to have managed services, okay? When AWS or the cloud provider, takes care of the scaling, fault tolerance, and availability. That's something that AWS provides. And I believe that the other providers and Microsoft offers it too, but it's a little different. But my guy is AWS. I'm not supposed to give you my opinion because it's a biased opinion, but I prefer AWS. But you're free to prefer whatever you want. So difference between unmanaged and managed. Unmanaged, you have to run with all the patching, maintaining, and scaling and fault tolerance, everything. Managed is done by AWS. Very good to trust AWS. So here we have all the services, platform services, I'm sorry. So we have other services like AWS Lambda. By the way, when you talk about Lambda, it's the Greek, the Greek symbol, Lambda. But Lambda is a function. It's a function. And Lambda is a compute serverless service. Why is Lambda popular? Well, Lambda is thought to substitute and replace EC2 instance, EC2 in the near future. Why? Because EC2 instance is a server, right? It's a server. You don't have to worry about many of the stuff of the AWS servers, but it's a server anyways. AWS Lambda is serverless. You don't need servers. You know what you do with Lambda? You just upload the code and it will take care of the rest. That's it, as simple as that. Lambda, you upload the code and watch it run. That's it, simple. So with Lambda, you can create a lot of things. You can create different functions that can upload pictures in S3 buckets. You can do so many things with Lambda. You can stop instances. You can stop your servers at 5 p.m. You can start your services at 8 a.m. every day. You can do so many things. You can terminate services. You can do so many things with Lambda. A Lambda function will do that for you. We're going to see some examples in class, how to stop servers in the afternoon, or how to start services in the morning using a cron job. Probably you know what a cron job is. It's used by developers and administrators to automate tasks. And we can do that with Lambda too. And with CloudWatch. Remember what I said about CloudWatch? CloudWatch is one of the most important services in AWS. You can schedule tasks with CloudWatch. Any questions so far? Do I still have you here, guys? Am I losing you?
Still here.
Still here.
Okay, good.
Me too. Me too.
Are you understanding?
Yes.
Good.
Yes.
So we have compute services, we have databases, services, analytics, Kinesis, Elasticsearch, EMR, Elastic MapReduce. We're gonna talk about that later. We have SQS for decoupling, decoupling, SNS, SES, simple queue service. simple notification service, simple email service, Amazon Step Functions. Lambda is a great service, but Lambda has a limitation. Lambda has an execution time of 15 minutes. If your application runs for more than 50 minutes, Lambda is not the service. Even though Lambda is serverless and it's a great service, it is not suitable because your application needs more than 15 minutes. So what's the solution? If you want to use several functions, okay, that have long execution time, well, you can use something called Amazon Step Functions, where you can have several functions in different tasks, and then you can run all the functions one by one. We're using Amazon Step Functions. AWS Commit, that's for developers. If you know about GitHub, AWS is the code commit version of GitHub. Code deploy, code pipeline, code build. This is the like Jenkins. And X-Ray is for debugging. Know everything that is happening for a particular service. So we have Cognito for Amazon authentication. Okay. We have Amazon Pinpoint, that's for marketing, marketing, email marketing. And then you have Amazon API gateways to work with APIs and HTTP requests and all that. So cloud scenarios. So we have here only the cloud and hybrid. Like I said before, Netflix was the first one to go all in the cloud. So all in the cloud is you have your service fully deployed in the cloud, and all the parts of the application run in the cloud. So these applications have been either created from zero, from scratch in the cloud, or have been created outside the cloud and then migrated to the cloud. So there could be different scenarios here. Now, cloud-based applications can be built on low-level infrastructure pieces, or can be used in high-level services that provide abstraction from the management, architecting, and scaling requirements of core infrastructure. So it is abstracted away from you, so you don't have to worry about that when everything is all in the cloud. Now with hybrid is suitable for business owners or businesses that want to keep control or some control of their data or their infrastructure, because like the word says, is hybrid. It's certain percentage in the cloud and certain percentage stays on premises. So you can reach out to the cloud through several services. You can connect them using a hybrid infrastructure. Many companies decide to go with this hybrid thing because they don't trust cloud providers 100%. So they still want to keep some control, specifically in the security part. Okay. So with the cloud adoption becoming the new normal for enterprises, the next level debate is now about the specific approach to take when migrating to the cloud. So what approach do we take? When you see the word monolithic, it's something uniform, something compact, something united, right? Now, if you know about microservices, you're gonna know, the advantages that microservices have. Monolithic, the problem with this is that if something fails, the entire thing fails, okay? And that's not good. What happens in the cloud is that you can have decoupling and you can have microservices, and that, what happens with that is that if one component fails, the others will continue running, okay? So AWS offers that too. So we have it here. We have the corporate data center, file publishing. So at the most fundamental level, hybrid computing can be viewed as having data that resides both on premises and in the cloud, right? So we have a monolithic application here. in the cloud, and we have a corporate data center. Now, this is often done to economically store large data sets, utilize new cloud native databases, move data closer to customers, or to create a backup and archive solution with cost-effective, high availability. In all cases, AWS offers a range of storage database services that can work together with your on-premise infrastructure. That's what we talk about, like hybrid lift and shift, right? Lift and shift is moving your services from the corporate data center to AWS, either all in or hybrid, okay? So that's the lift and shift. That's what it means. So we have here what I talked about before, the monolithic application here, where everything is united, all the users are using one particular file ingestion, the processing, publishing, everything's only one, right? Now here, so we have the microservices, okay? So the users can ingest the files here. You put a message here, then the message is ready for processing queue. You know, this is what we talked about, the SQS, remember the simple queue service, is used for decoupling, right? So the service come here, you put the message, ready for processing queue, then the files process here. Okay, so this is the process, the coupling. While you have the service, the message here, the message is like, it's like an order to process a specific file or something. So it decouples. Why? While the message is here in this queue, what happens is that if this server fails, the message is still here. You see, it decouples the application. If this fails, then you still have the message here. You may lose the server, but you still have the message here. Now, what it means is that auto-scaling can create another EC2 instance, and then you can still work here. So for queues, we have consumers and producers. So we have the one that produces the message, and we have the one that consumes the message. Like I said before, what can be a queue? For example, you order something from a website for a store. That order is a message. It gets into a queue, right, to be processed. Now, if that website goes down, your order is not down. Your order is not down. It's still in a queue, decoupled. So that's what microservices achieve, and that's what they offer. You can have different services, micro. That's why separated services working together. But if one fails, that one is the other ones are not dependent on that one. They can still continue working. So once the file is processing, you can push that file into an S3 bucket, right? And then the users are giving access to that particular file that is public, by the way. So in an S3 bucket, you can have public or you can have private files, okay? But that's not something, by default, is private. You have to make it public, right? So once the process is complete, what happens? At AWS, we use Amazon SNS topic to send a message to the subscriber saying that you could get the file, okay? In this case, the subscriber can be the business owner. It's not the user. The subscriber is the one that has the services with, the business with AWS, right? So you can get a notification that the process is complete. This is a high-level explanation of what happens when you use microservices in AWS. Microservices is not only for AWS. Microservices is for any type of technologies that you use for any infrastructure. But in this case, we're talking about AWS. So benefits of microservices infrastructure. We can have agility, flexible scaling, demand high, more, demand low, less. Easy deployment, we can deploy our infrastructure globally really in minutes. It's easy. Technology freedom, we can use sometimes the open source, we can use any technology we want. Even though some platforms service in AWS have a limited range of languages that they use, programming languages, we can have reusable code in the clouds. In the case of CloudFormation, that we have templates that we can reuse to create other services. And of course, we have resilience, how strong and fault tolerant this architecture can be. Okay. So what are the best practices? We can change components without breaking them. So very important, always change your components without breaking them. In the case of microservices, the good thing about microservices is that you can change one component, and if it breaks, the other ones will not be affected at all, because they're separating as small services, and at the end, you bring them all together, and then you have your application. But you can separate it into small microservices, and then they're independent on each other. So we can, the interface is a contract. Modifying capabilities should not affect consumers. Why? Because if you modify one and it breaks, the other ones will continue running, so it doesn't affect the user's experience. You can use a simple API. Try to make it as simple as possible. I mean, when I say try, is best practices. This way, it can be easier to maintain and change later. If it is simple, you're not the only person working with this services. There are other people that are working with it. It's very important to keep it simple, so that others can understand and they can follow through. More complexity means more resistance to change. If you're a guy that is always bragging about your programming technology knowledge, and then you want to write in Chinese, for example, writing a code that nobody understands, only you are the one that understands it, or probably few people understand it, that doesn't make sense, man. It's only for you and those few people. You have to write it as simple as possible. Less complexity is more or less resistance to change. So that's very important. The less you share, the less you break. Share with only the people that are closely related to the application. Don't share it with anybody. Because when you share, people try to add things sometimes, and it can break it. Okay. And you can hide the details. You can abstract away things that you don't want other people to know. Okay. That just by making it simple, that's what you can achieve. Now, treat servers as stateless. What's the meaning of stateless? It means that the server doesn't keep track of the state. The state is that the server doesn't know who's accessing the application, who's sending the request, who's sending the response. That's what decoupling does, right? You can do this statelessly, and it's going to be better. Servers should be seen as interchangeably members of a group, right? When a server is no longer useful, you can easily dispose of it and create another one. That's why we can treat them as stateless. They don't keep any state. So server and server is server. That's it. It's just a replica. When autoscaling creates a new server, what it creates is a replica of the current server. That's what it does. If you lose one, it doesn't matter. Another one will be created. That's what happens. So you can focus on determining if you have enough capacity to handle your workload. You have to determine that before you start anything, any architecting in AWS, you have to think about your capacity, right? And from that moment on, you can start setting up your auto scaling and load balancing guys, and then you don't have to think about that anymore, okay? You have to know how often this business have high demands or low demands. That's very important to know, okay? Because if you know that you're gonna be busy for the entire year, what is the point of using on-demand servers? You can use reserved instances. You can reserve instances for a year or for 3 years contract, and then you don't have to worry about that anymore. And of course, the more you buy, the more you save. If you know that your capacity is fixed for the entire year, instead of buying on-demand servers, buy reserved instances, and that's it. That's it. So adding and removing instances with auto scaling is much easier with a stateless approach, right? You treat them as stateless and forget about the rest. It will create, auto scaling will create or remove services, servers. Decoupling, what is decoupling? Like I said before, you can separate services from others, okay? And you're gonna be more resilient and more for fault tolerance. Before I continue, does any one of you have any questions? You still there, guys?
We're still here, yes.
Oh, I'm sorry, I hear
Yeah.
it.
Yeah, no, following along.
Okay. Yes, maybe I'll be talking to you in Chinese, but you know, it's don't
No,
panic.
you're not.
Don't
No,
panic.
you're not.
Okay, thank you.
Yeah, I have a question,
Go ahead.
Janeski. All services from AWS, AWS develop and make all that services. Where is the technology background that services? For example, database background is Oracle, SQL Server, Microsoft.
Yeah. Well,
Where is the technology background, the AWS services?
okay. For EC2, you should know some Bash scripting, because you may want to install an Apache server on your EC2 instance to have some, browsing some internet content there. For Lambda, you should know at least a programming language, because Lambda uses Python, it uses JavaScript. When we get to Lambda, we're gonna see that. For RDS, which is relational database, you would need some SQL knowledge, because it uses SQL Server, it uses Postgres, it uses Oracle, all those relational databases, and then you would need some knowledge about structured query language. And for example, there's another service called Athena. Athena is an interactive query service where you can have tables display on your console, getting the data from a bucket in S3. For example, you can use Athena using SQL to display columns and rows in your console. For Elastic Beanstalk, you should know some language as well. From CloudFormation, you need to know YAML or JSON, which is object notations. But I don't think that for the other services, for example, for ECS, you should know about Docker, how to use Docker containers. I think that for most services in AWS, you need to know how to use the console and the CLI, okay, to create services. But there's just a few services that require a specific technology. Like for example, for VPC, you have to know about networking. You have to know about networking, IP addresses. You have to know about CIDRs. You have to know about subnetting. You have to know about that, right? For security, you have to know about DDoS attacks, denial of services attacks. You have to know a little bit of everything for the AWS cloud. Does that answer your question?
Yeah, I understand. It's a combination like open source technology and proprietary technology.
Correct. That's correct.
Okay.
But
Thank you.
guys, if you study AWS as you should, you're gonna fall in love with it. It's amazing. It's awesome. You know, when I saw the first, I cannot tell you it was a love at first sight, but as I got into it more in depth, I became in love with it, and that's why I decided to go for more certifications, like 5 certifications in AWS, because it's amazing. It's amazing, and it opens a lot of opportunities for you guys to find a job, because it's a plus to know about the #1 provider in the world, cloud provider in the world. It's a plus. It's an add-on, a huge add-on to have a certification from AWS. I can tell you that. Okay. So Lambda is a trigger, is an event trigger function. It's triggered by events. And how do we create those events? In CloudWatch. CloudWatch has event rules that you can create, and then those rules, when something specific happens, it will create a Lambda function, and the Lambda function, for example, says stop an instance, and then it will go ahead, boom, and stop the instance in the EC2 console. A Lambda function can trigger a specific cron job. You know that, for example, every single day at 5 p.m., run AWS manager, system manager, and run some patching on every single EC2 in my infrastructure. So Lambda is one of the most powerful services that AWS has right now. Like I said before, it may replace EC2 in the future. That's what I'm thinking, because it's serverless. You don't need a server. And serverless is very popular now. Serverless architecture is very popular right now. So you can create your own backend services. You can focus on developing great applications. You can run the code, not servers, okay? You don't have to run servers, you run the code, okay? Unlike EC2 instances that you have to run the service, okay?
I couldn't hear what you said.
Thank you. Okay, so we continue. My iPad is talking to me. I don't know why. Okay. So, for microservices here, same graphic that we saw before, same picture. So we don't have to say anything about this. Now, I just want to add that when you access some content in an S3 bucket, the way you access the S3 bucket is through HTTP requests. So you will be provided with a link that gives you access to a particular service. Okay. So can you see my screen here?
Yes.
Okay. So we have AWS. Don't worry, we cannot cover the 2 PowerPoints. We have tons of time in this class. Okay? So we have AWS, Amazon. That's the console, management console in AWS. Can you see my screen?
Yes.
So we have here, we can access an S3 bucket either by typing S3 here, right? S3, you see, S3, or simply just going in here and going to the storage section and click on S3. And once you access S3, it's gonna be pinned here. So you don't have to go type or anything, just click here and that's it, okay? So I'm gonna click here. So here we have the console of S3, right? Now I'm gonna create a bucket and come here and create a bucket. What is a bucket? A bucket is a container, right? It's a container where you save all the objects, because remember, this is object storage, S3, right? So the name for the bucket is unique in the entire world. It's not in your infrastructure only. It's in the entire world. So if I put my bucket, do you think that's gonna be taken? Of course it's gonna be taken. So if I go here and I try to create it, you see here, bucket name contains invalid characters. What do you mean by invalid characters?
Can you zoom in?
Oh, yes. So it says bucket with the same name already exists. You see there?
Mm.
But I don't think that anyone is gonna have this one, right? I don't think that anyone is gonna have Dunieski. I don't think that. Now we can choose the region here. You see all the regions that AWS has, other regions. I'm gonna stay with US East North Virginia. This is the most popular region, US East 1, right? So I just keep it there. By default, all the public access is checked. I mean, it's restricted. No one can access my bucket unless I give him permission. So this is blocked, all public access. I'm gonna leave it that way right now. So, okay, I don't know why it's telling me this.
Excuse me, do you want us to follow along?
If you want to, we're gonna create buckets later. I just wanna show you how you access an S3 bucket. So let me see this. Okay. Okay, create the bucket for me. So the bucket is here, right? Now, if I do this, and I upload a file here, right? I can upload a file. I can just drag it and drop it here, or I can add the file by clicking on Add Files. I can just put a picture of me. No, maybe not. Okay, one moment. Let's see if I can find something for you here. Okay, this one, good. So I can just upload it. Here I have the option to encrypt it. Here, right now it's private, then go here, and then I can choose the class. You see Glacier here? Remember I spoke about Glacier for archiving? Here, I can choose Glacier, or I can create a lifecycle policy. We're gonna talk about that later. And it will automatically, after 30 days or 90 days, it will move the file to Glacier automatically. That is achieved with a lifecycle policy. Okay, so now I can encrypt it here. No, it's not encrypted, right? Or I can encrypt it. Okay. I'm gonna leave it that way. Okay, so I upload it, and it's uploaded there, right? Now, if I click on it, I choose, okay, I chose Glacier and didn't, okay. Let me load it again, okay. Okay. So right now, you see this is an HTTP, this is an URL, a uniform resource locator. If I give you this right now, you would not be able to access it because it is private, right? Access denied. You see there? Access denied, right? So I have to make it public. And how do I make it public? I can come here, back to the bucket. I can select it, go to actions, and then in actions, I make it public. But you know, we have a problem. I cannot make it public. Why? Because in the first place, the bucket is private. So what I have to do, I have to come to the bucket, click on the bucket, and then select here, permission, and then here, edit the permission. And when it's enabled, I can uncheck this, right? Now I'm not blocking the public access. So I can come here again, save it, confirm by typing the word confirm. You know, they want to make sure that you know what you're doing, because this is going to be public for the entire world. I can confirm it here. Public settings updated successfully. Right now, I can go back to the bucket, and in the bucket, I can make this file public. So I can come here to the actions, and now is not graded out. I can click on make public. Make public. I don't have to confirm anything because the bucket is already public here. Now, if I give you this link, and I just put it here in the chat, right? Now, if you click on that, you're going to be able to see my picture, or the picture that I posted there. See there?
Yes.
Okay, because this bucket is public. Okay, so that's the way you access resources in a S3 bucket. And of course, it's serverless. It doesn't need any server. There's nothing here that needs a server. Nothing. Remember in the previous microservice thing, what do we have here? Can you determine this symbol, what this means? You have an idea? When you see this orange square here, you know what it is? An EC2 instance. This is a server, an EC2 server, right? Now, when you have this one, what is this? Lambda, right? It's the same process, but instead of using servers, we are using Lambda, which is a serverless service, right? So we're not using any kind of service here, okay? So this is serverless. Architectural evolution, okay? So we have EC2 instances at the beginning. EC2 instances is one of the oldest services on AWS. Number one was SQS, Simple Queue Service, and EC2 was the other one on that. Then we have Amazon ECS, Elastic Container Service. This is for running servers on top of these containers, right? Containers are independent of each other. They run independently, right? So an Amazon it has a virtual machine. It's a virtual machine. It's a server in the cloud. Amazon ECS, it works with task definitions that you have to create when you work with Amazon ECS. And then you have to have a Lambda function when you work with Lambdas. Level of abstraction, it has the hyper hardware, and there you have to have hardware. that is abstracted away from you. You don't have to you don't have to deal with the hardware, but AWS has to do it. With Amazon ECS, we need the operating system. That's what we need. And for Lambda, we need runtime. You just upload the code and just let it run. How do I choose? I want to configure server, storage, networking on my operating system. Then I choose Amazon EC2, right? But if I want to run servers, configure application, control scaling, I can use ECS. But if I want to run my code when it's needed only, I can use AWS Lambda. One of the advantages of AWS Lambda is that you don't have to pay if you don't use Lambda. You don't have to pay for that. So it will run the code only when needed, right? When you have the demand. That's it. No more than that. Infrastructure overview. Guys, do you want to take a 5 minutes break?
Yes.
Yes. Okay. I will see you here at, how about 2:50? Is that okay?
Perfect.
Okay.
Thank you.
You're welcome. Okay, guy, 250. 250.
Yes.
So everybody's back?
Yep.
Yeah.
Good. So there was one student asking me if I could delete. Remember, I uploaded a file in AWS, and it was in Glacier. And then I uploaded again. It was in a regular S3. What happens is that when you do that, what I did, it overwrites the file. So when I uploaded the file again, and I uploaded it in S3, it never created it in Glacier, because for Glacier, can you see my screen?
Yep.
Yeah, in Glacier, you have to create a vault, right? You have to create a vault. In S3, you create a bucket. In Glacier, you create a vault, right? This is the container for archives, right? So you give it a name, and then you want my vault, Dunieski. Do not enable notification. You can choose whatever you want here, and then you submit, and you create a vault, right? Now in this vault, you can just put the files here, creating a lifecycle policy, right? I don't need this vault right now, so I'm gonna delete it. But if I go back to S3 and I go to my bucket here, there's something called lifecycle here. I can create a lifecycle, and then I can give it a name. Let's say my lifecycle policy, let's say Dunieski. You can select limited the scope of a specific prefixes or tags or apply to all objects. I can do this. And then I can do the current versions only of the previous versions, whatever you want. And then I can do this. I can select expiration. You see, after 365 days from object creation, I can acknowledge here and move it to whatever I want. Okay. This. Okay, you can add a transition here, and you can move it to Glacier after 90 days, for example. Okay, you acknowledge here, and then expiration after a year. I don't want the files to be in my my archiving or anything. I want it to disappear after a year. So I just save this, and whenever I upload a file, any object to my S3, it will follow this lifecycle policy, and after 90 days, it will go to Glacier, and after 365 days, a year, it will expire. Okay, so let's say you have a bunch of files in your S3, and they're not accessed frequently. You don't want them to be there anymore because they're occupying space that is not needed for those files. So you create a lifecycle policy and move them to Glacier or to another class, storage class like IA, infrequently accessed files, standard, and then you can put it there. And whatever you want. You can do whatever you want with the lifecycle policy. Okay? I'm gonna delete this lifecycle policy. I don't need it. Okay? So that was a little demonstration of S3. We're gonna do more later. For now, it's for you to have an idea how to access a particular object in AWS, in S3, AWS S3. All right, so a single data center typically houses several thousands of servers.
Yes, Ricky.
Typically, yes.
I have a question,
Go ahead.
Zuleski, again, Otmaro. Regarding the Lambda services, I don't understand serverless computing. Is you need a processor and a primary memory RAM.
You need,
What
okay.
that service that how it works? I don't understand. It's SIX, it's RISC. Okay, what kind of technology is this?
Let me create a function, okay? Let's say that, let me call it, create a function here real quick. Create a function, I'm gonna call it my first Lambda. I'm using here camel casing. This is very typical in programming. You know, when the first word starts with a lowercase and then the first letter of every word is capital case, right? Uppercase. That's camel casing, right? My first Lambda function, right? I'm gonna use, I can have different, you know, platforms supported here. I can use .NET Core, I can use Java, Node.js, Python, Ruby, .NET Core, Java 8, Python 2.7. I'm gonna use here, I'm gonna use Python 3.8, okay? Now, don't worry about the role now, because this role, when we study IAM, identity and access management, we're gonna know about roles, okay? So for now, we're gonna create a role because a role is needed for services to interact with each other, okay? The only way a Lambda function can work with a specific service is by having a role that gives it access to that service, okay? That's why we create roles in AWS. Now, this Lambda function is gonna create a basic Lambda role, right? To access whatever service I decide to access, right? So I'm gonna create a function here. I can use an existing role if I want to, right? And I look for these are roles that I created before, right? I can create a new role, whatever I want, right? I can create a function. No, I'm gonna select create a new role. Now I have to wait. Now, who was the one that spoke? Is that, what's your name? Hello? Can you hear me?
Yes.
Oh, I don't see anyone responding.
No, we can hear you.
Okay, so what's the name of the person or the student that asked?
Otmaro.
Amaro. Okay, Amaro, we didn't create a server here. No server, right? This is serverless, right? Lambda is one of the serverless services of AWS, right? There's no server. We didn't create any server. There's no server running here. What we have here is memory. You see here? Memory is what we have here. That's it. Memory is directly attached to CPU. More memory, more CPU. That's the case of Lambda, right? So we have a central processing unit here that is working with this Lambda function and is directly proportional to the memory, right? That's all we need. We don't need an operating system. We don't need anything. We don't need any server, right? What we need is this code right here in Python, and that's it. Now, this is gonna print hello from Lambda. Okay. Now, I can test it here. I can come here and test it, right? So if I'm come here, just give it any name you want, my event. This is for a basic Lambda function, okay? My event. We don't put anything here. We don't need any of this, okay? So we create it. And now we test it. And then we get a print here. Hello, Lambda. Okay? So this is a serverless solution that is triggered by events. Okay? And we're gonna hear more about this in the future. But for now, you need to understand that it doesn't use any servers. It's just simply serverless. Okay? It's a function that has code. In this case, is Python, and the files here. And it prints something when you trigger that event. Now, before you run it or before you integrate it with other services, what you have to do is test it, is what we did now. If you get this check mark here and this green color and it's executed, then the Lambda function works, right? So I'm gonna give you some examples later on in the course about how Lambda works. But for now, we don't need a server. It's serverless. Okay? So if we create an EC2, this is a server. Okay? We launch an instance here. Then we have to choose an AMI. More later about EC2. It's just an example. You see here, we have to choose the type, right? The virtual CPUs, memory in gigabits. You see all the different types of EC2 instances. Now we have to do the configuration. We have to put this inside a VPC. In this case, as a default VPC, right? We have to choose a subnet. We have different subnets here. So you have to put your server inside a VPC. We have to enable auto-assign public IP. You know, you can have a placement group. The capacity can be open, none. You can have a role as well to interact with other services. You can have a tenancy that is dedicated host or dedicated instance or share. People usually use share. You can have an Apache bash script here to create, create some patching, to download an Apache server, whatever. So my point is, this is a server, like a computer. You have to put it in a network. You have to put it inside a subnet. You have to give it some power, some CPU, RAM. You have to choose the instance type. You have to just state if it is shared or dedicated. You have to create the storage. In this case, it's a root volume. You can add another volume here and choose the different types of volumes. Okay. Next, you can give us some. We're gonna know more about this later in the course. Just give an example. This is a security group. This is a firewall. That's the firewall. We have to open the ports. In this case, we open in port 22, but we can open any port we want. It can be HTTP, that's 80, HTTPS 443. It can be SSH 22. It can be DNS 53. It can be another one here, RDP 3389. You know, any port that you need for access, right? Then you can launch it. You can launch it, and here let's launch without any key. We're gonna know more about this later. Just an example, and simple. we just created a basic server, and it's here, it's pending, right? So that server, like any computer in this life, it has a public IP, right? It's gonna have a public DNS, right? Which is this IP as a URL. Remember, DNS, what it does is interpret this and solve it, resolve it to an IP address. This is what the machine understands, right? But if you use this, the DNS service will translate this to an IP address. And of course, the machine will also understand this, the browser, right? This is a Linux server, right? What else do we have here? We have the VPC name, the virtual private cloud. This is a default one, but we can create one if you want to. The subnet ID, if you click on it, we'll take you to it. It's right here. Okay. This is the information of the subnet, all this information here. So as you can see, it's beautiful. It's beautiful. It's so well done, so well created, so well thought out that you fall in love with it. Okay, you see the server's already running, right? If we happen to have an Apache server, we can just click here in the IP address. We can just copy and paste this. Of course, that's going to show anything now. It's going to hang there forever, right? But this is a URL that we use to display whatever content we have in this EC2. I'm going to give you some examples of different HTML code that I'm going to put in a server. And then when you just type in this URL, you can see whatever I created in my HTML file for websites. Okay, so this is high-level explanation of EC2. Okay, you can have this monitoring, to check the health of this EC2 instance, this ECP2. Okay, this is what we consider when we create an alarm and auto scaling. This metric is the one that we use here, right? And how do we use that? In CloudWatch, right? We can use it in CloudWatch. We can use enable detailed monitoring, but that's gonna cost you money. So we don't care about that. Now, if we click here, we can see the same metrics in CloudWatch. So we get here EC2 per instance metrics. And then here, we can see of this particular EC2 instance, we can see here there's nothing because we haven't used it. But we can stress this particular EC2 instance and we can see how the CPU usage skyrockets. All right. So a little bit of EC2, a little bit of Lambda. We're going to know more later. For now, that's all you need to know. But my point, Otmaro, EC2 instance is server full, Lambda serverless. Okay.
Yes, I understand. But my question is about where is the technology behind the Lambda services? Is virtual machine?
No, it's not server. It's server. It's a function that they created. It's a function that runs with code.
For example, for a SaaS application, what do you recommend? Lambda or EC2?
It depends. If you want to go serverless, it depends on the customer.
If you need a storage application in a server.
Yeah, for server, yes, you have EBS, a volume here, right here. Why? This is not easy to console. One moment. Here.
Yeah, I got it.
Volume, right? You create a volume. That's storage.
Yeah.
For Lambda, you can use S3, which is serverless, right?
Okay.
This is attached to a server. This needs a server. S3 is independent. It doesn't need a server. But for volumes, you need to attach it. You can create it here, but you need to attach it. You say here in use. In use, it means that the EC2 that I just created is using this volume. If I delete that EC2, the volume will disappear instantly. So I have the instance here. If I click on that, an action, instance state, and I terminate it, then it's gonna start shutting down. Like right now it is shutting down, right? Now, if I go to the volume, this volume will disappear instantly as soon as the EC2 is terminated, because it's attached to that. Now, S3 is not attached to anything. It's serverless. This is attached to a server, okay? But this is a storage that we use for that. You can also use S3 for EC2 if you want to. It's cheaper than EBS, Elastic Block Storage. By the way, this is not EBS. This is instant store. This is volatile. This is like RAM. If you lose the computer, what happens to your RAM? If you turn off your computer, what happens to whatever is saved in the RAM memory?
Gone.
It's gone, right? This is like RAM. EBS, whatever volume you create, you can save it before, you can create a snapshot right here before you terminate the instance, right? Now, the EC2 instance right now, it should be gone. You see? Terminated, right? Now, if I go to the volume section, gone, right? So it's like RAM. Computer's gone, RAM is gone. Computer's off, RAM is gone. EBS is more persistent, right? Now we continue here. Like I said before, there are around 50,000 to 80,000 servers in a data center, okay? So AWS is structured this way. Regions, like I said before, regions, availability zones, data centers. A region has minimum 2 availability zones. Why is that? Why do we have 2 availability zones? Do you have an idea?
Redundancy.
I'm sorry?
Redundancy.
Right, redundancy. If one availability zone is down, we still have the other one, right? So AWS recommends 2 minimum, right? 2 minimum. And AWS recommends 2 servers minimum per availability zone. 2, because one is down, the other one can still run. Now, the focus of this exam is high availability. That is the focus of this exam, right? When you are an architect, you have to think highly available all the time. You have to architect in a way that your application will always be running, no matter what, okay? So all data centers are online, all of them. All of the AWS data centers are online. They're never cold. They're always up and running, okay? That's how stable and how highly available AWS is.
A question, 2 servers active or active-passive?
They can have both.
Both active?
Yes, they can have both.
Okay.
They have different recovery, disaster recovery things, ways to do it.
Okay, thank
They
you.
have 4 different, we're gonna see them, the 4 of them. 4 different strategies for recovery, disaster recovery. So we have here the regions and availability zones. We have, here we have the data center. in one availability zone. We have another data center in one availability zone. Remember what I said, every availability zone has at least one data center, at least one data center, okay? It's a geographic location, okay? It's about 50 miles away from each other. Very important. Availability zones are 50 miles away from each other, okay? They're not that far, they're not that close, okay? But all of this is with resiliency in mind, right? Redundancy. So in this region, it could be any region, we have 2 availability zones, 2 more. We have the other one here. We have 2 data centers in one availability zone, 1 or more data centers designed for fault isolation. If one availability zone is down, the other one has nothing to do with that one. So they're isolated from each other. They're interconnected with other availability zones using high-speed private links. Those are private links that Amazon has, AWS has. They're theirs for our consumption and AWS consumption. You know, it's private, and they're connected to one another. So here we have some of the regions in the world. We have in Oregon, North California, we have this Gulf Cloud, that's for the government, okay, very dedicated. North Virginia, London, Paris, Frankfurt, Ireland, Mumbai, Singapore, Sao Paulo, Sydney, Osaka, Tokyo, Seoul, and Beijing, and Nixia. So we have all these regions in the world, and I think they mostly cover the entire world. If you live in Russia, you're going to be rerouted to probably in Beijing or probably Frankfurt, but you're going to be close. You're going to be close. And right now, there are 24 regions, and I think they have 3 more in the works. They constantly adding regions and regions and regions, and they have like 84 availability zones. So that's a lot of redundancy. Okay. So something that you may not know is that not all services are available in every availability zone. So whenever you create a service, you first have to see in what availability zone the service is available. That's very important. And the price and the cost varies from availability zone to availability zone. Okay, that's something important to understand. So here we have some more coming soon. This map may not be completely updated, but we have one in Sweden, another one, there's another government one in US East. There's another one in Bahrain coming soon, and then Hong Kong coming soon. This is awesome. See, they're creating more and more and more. Okay, it's a super powerful company. So now, when selecting a region, that's very important to know. What are the factors that we have to consider? The data governance legal requirements. You have to know if the data you're using complies with the local regulations of the country or city where your servers are, where your data resides. So you have to determine the right region for your services, applications, and data based on these factors. That to ensure high performance for your customers, you have to select the region closest to them, thereby minimizing latency. User experience is crucial for any business. So sometimes local laws will require that certain information be kept with the geographical boundaries of a country. Such laws may restrict the regions in which you can offer content or services. This is important for any architect to consider. So new AWS services tend to roll out gradually across region. The proximity of the customers, that's crucial too, because they want to have the data as soon as possible. They don't want to waste time. They may switch to a different website if yours is extremely slow, or is yours is slower than they need. So proximity to customers is crucial. And this is one of the advantages of AWS, is that as they have so many regions and so many availability zones and so many edge locations, the latency is very low. And that's where guarantees more customers. You have to see if the services that this business needs are available in this region, okay? If they're not available in this region, what you can do is select a different region. Select a different region where this service is available. And the cost vary by region, like I said before. So these 4 factors are factors that an architect should consider when creating an infrastructure. Architect an infrastructure, okay? Very important. You're gonna be tested on this in the exam. So introduction to AWS Foundation Services. So here we have Amazon EC2 Elastic Compute Cloud, EC2. We have Elastic Load Balancing, ELB, also known as ELB. And we have an AWS Autoscaling. By the way, Elastic Load Balancing and Autoscaling, they work together. They're friends, they work together, okay? So Amazon EC2, you pay as you go, right? You pay as you go. You don't use it, you don't pay. You use it, you pay. As simple as that, right? You have a broad selection of hardware and software. They have a lot of instance types that you can choose. They have Amazon Machine Image. What is an AMI? AMI, also known as Amazon Machine Image, is a template that contains all the resources and all of the softwares and the operating system that we're gonna use when we create that EC2 instance. That's an AMI. It's an image that contains everything that we need for that particular EC2, right? Now, you add more instances when you need them, and you terminate them when you don't need them. As simple as that, right? Like I said before, an EC2 instance is just a copy, is a replica of the other ones that you created. By the way, when you create an EC2 instance, you launch an instance, right? Guys, are you with me?
Yes, yes.
Yeah.
Yes.
Yeah, yeah.
Good, thank you. So when you create, and you choose here, what is this? Can you read this? Can you read it? You see my selection here?
Yeah. Amazon Relation Database Service
Yeah.
makes it easy to set up, operate, and scale your database on AWS by automating time-consuming database management tasks. With RDS, you can easily deploy Amazon Aura, MariaDB, MySQL, Oracle, PostgreSQL, and SQL Server database on AWS.
Okay, thank you. I'm sorry, but that's not what, I'm sorry, my bad. You see the number one says Amazon Linux 2 AMI. You see here? You see, I'm selecting it now. You see there?
Uh-huh.
Yes.
Okay. We need an AMI to create a server. That's number one requirement. We need an AMI. It's right here. This is what contains everything that we need for this particular server. So when you click select, now we choose here the type, the one that comes with
Free tier.
the free tier is the T2 micro. It's right here, T2 micro. Okay, that's the smallest one. That's the one that comes with the free tier. So I selected that one. Now here we can create 10 EC2s. You see the number 10 there?
Yep.
Okay, I can create 10 EC2s. I can create 20 EC2s, right? But we have a problem. If I do this, it would not create the EC2s. Why? Because the limit for new accounts is 20 per region, right? The limit is 20. You may have in the test, don't forget that, because I remember having this question in my solution architect exam, that one company wanted to create 21 or 22 EC2 instances for a new account. If that's the case, your answer should be that that's not possible, because the default limit for any new account is 20 EC2 instances, right? So I can create 20 EC2 instances at once, and then let me choose here, whatever. Okay, I'm gonna choose here this here. Actually, okay, let me go here. Okay, that's what I need. I'm gonna launch it. And this is absolutely crazy. I'm creating 20 instances. My God, I can be charged a lot of money, right? So if you take a view all instances, look at that. That is absolutely crazy. So I have to delete them, all of them, immediately as soon as they're created. I don't want them. Okay. Now with the CLI command line, we can create this with 2 lines of code. So simple as that. That's why knowing the CLI as a solutions architect is crucial too. Now the CLI is based on Linux. Does any of you know any of Linux? Any commands on Linux? No?
Some.
Some
Yeah.
limited.
Limited? Okay. Okay, one moment. Just give me 1 second. Let me see here something. Okay, this is my CLI. Okay, this is my CLI. All right. I can use the command clear, and then I clear everything. All right, clear. I clear everything. Now, if I do this, AWS EC2 describe instances. Okay, for every single command in the CLI, the first part of the command is AWS. AWS has to be in every single command line. Okay, the second one is the service we're working with, EC2. And this is the operation that we're gonna have. Okay, so don't do it in your CLI because it's not gonna work. Okay, you have to configure your CLI. I already configured mine. I will help you configure it. Don't worry. So if I do this, look at that. It's gonna give me a detailed breakdown of all my instances, the 21s that I just created. Look at that. That's absolutely crazy. You see? You see? Beautiful, right? Isn't that all the 20 instances? You see? Right, you see that? Now, don't worry about that now. I'm gonna help you how to configure your CLI when we get to that point, okay? I just give you a demonstration of how you can, remember the bucket that we created, remember? Okay, if we want to see everything that is in the bucket, what's the first component of a command? What's the first component?
AWS.
AWS, what's the service?
EC2.
No. If you want
S3.
S3, and then we can do LS. That means list. If I do this, you see my bucket there?
Yep.
Oh,
See how beautiful it is? Now, I can create a new bucket. I can say, what's the first component of a command?
AWS.
AWS, what's the service?
S3.
S3. And now we can do, the command is make bucket. See, make bucket. And then we're gonna give it this URL or file system here to create a new bucket. Let's say my second bucket, Dunieski, right? My second bucket, Dunieski. Now, if I hit enter, put make bucket, right? Now, if I go back to my CLI, my console, I'm sorry, and I click on S3, boom, is there. You see there? Beautiful, huh? Now, I can do this. What's the first component? AWS. Second component, S3. Remove bucket, right? And then I do this. What's the name of my bucket? My second bucket, Dunieski, right? And then I click this. Okay. And then if I refresh this, it doesn't work because it's not RM, it's RB. And then if I just refresh, it's gone. You see how powerful the CLI is? So understanding the CLI, we can do whatever we want with the CLI. All this process of creating EC2 instances, okay? This 20 EC2 instances, this crazy thing with the console, okay? And by the way, all the EC2 instances are the same. They have the same AMI, they have everything is the same. So I can stop this. It doesn't give me the option because I have one that is terminated and it's selected. I unselect it and now I can terminate all of them. So I can do the same. I can do exactly the same with the CLI. Okay. I can do this. Let me see. Let me grab an AMI. Okay. I'm gonna copy this. I'm gonna come to this CLI and say it's AWS EC2 run instances. Image IDs. I can say count 20. Security group, I'm gonna use probably this one that allows browsing internet access, port 80, right? So I can say security groups. Let me see if it works. Just give me 1 second. So if you have a doubt, you can come here and say AWS run instances. Your best friend is going to be Google. Don't forget that. Google and AWS documentation. So you can come here and says image ID. I put an S. So if I do this, I put an S here, you know? Because actually I only need one ID, not more than one, okay? So look at this. It created all the EC2s for me. Now, if I go to my console and I just go to instances, what's going on here? Pending, 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 pending. You see, 20 EC2, new EC2 instances. Okay, so I don't have to go through the pain of going page by page to create this like you do manually. All of this, I can just do it in the CLI and accomplish the same thing. Now, if I create one more, what do you think is going to happen? Okay. I think my account probably switched to a pay account. Okay. Yeah, I can create more than 20, which is weird. Oh my God, this account is messed up. I've been charged more money than it's a good thing that I have a credit. Okay. So at least you understand how this works. Now, if I want to terminate all of them, I have to grab every single instance ID because the CLI doesn't know which one to delete. So you have to paste all of this one by one. That's not effective. I better just do this and just eliminate the ones that are terminated because otherwise it will not delete anything. And then here I do this. Okay.
I have a question.
Go ahead.
So the only time you can create more than 20 instances is when you have a paid account, correct?
Yeah, when you have a pay account, you can increase the limits.
Okay. Oh, but you would have to physically increase the limits and
You would have to request it.
oh, you have to request it. Okay.
If it is a pay account, it's going to have more. But if you want to go over the limit, you have to call AWS and request an increase.
Okay. And what differentiates from a paid account to like the account that we set up for our AWS account? What determines which one's a paid account and which one's not? Is that by tying in your credit card information, it becomes a paid account, or?
You see here, 20 instances. EC2 instances by default. AWS has a limit of 22 instances per region. This includes all instances set up on your AWS account. To increase EC2 limits, request a higher limit by providing information about the new limit and regions where it should be applied. Okay. I don't know why it's created more than 20. I have no idea. I created a bunch of EC2 instances. I have to look into that more closely, but this is the limit, right? Now, you have to request. This is for new accounts, right? Don't ask for more EC2 instances. I mean, for a higher limit now because this is a new account, right? You have no way to prove, unless you have a business, to prove what is going to be the use of that, right? Because you have to provide information about the new limit, right? Why you want those EC2 instances, that limit increased, right? And you have to see what region you're creating the EC2 instances in. In this case, you see, mine are in US North Virginia, right? Currently, all of the regions support EC2 instances, right? But there's some services that are available in one region and not available in others. Some services that are available in 2 or 3 regions and they're not available in others. So factors to consider, why you want to increase the limits and what regions you want to have your services in, okay? but this is the default, 20. Right? Any other questions? You're good students. You understand everything. I don't have any questions. That's good. Okay, so EC2 instances types. We have the instance family, general purpose, T2, M5, M4. That's something that you don't have to know so well for the exam, but it's a good thing to go on your own time, at your own time, and go online and check what they're used for. You know, this is a general purpose, as the word, as the name says. This is for everything. It's used for general purposes, for low traffic websites and web apps, small databases and mid-size databases. But, you know, keyword here, very important, low traffic, and small databases, small and mid-size, very important. If you need something bigger, much power, you have to scale up and you have to choose a compute optimized instance family. That's for high performance front-end fleets and video encoding. Now, if your instance require more memory, then you have to get the compute optimizes for when you need more CPU. If you need more memory, then you need a memory optimized. That will be in the range of the X1s, R4s. These are for high performance databases, Hadoop, Spark clusters. You may just investigate and research more about this Hadoop thing and Spark clusters. If your instance needs more and storage, then you should get the storage optimized H1, I3, D2. That's for data warehousing, local data processing apps. And if you need accelerated computing, then you are in the ranges of P3, P2, G3, F1. But for genomics research, machine learning, 3D app streaming. So as you can see, AWS covers a big range of instance families. It all depends on your needs. Whatever you need, if you have a small business that doesn't have any big traffic, or you don't have a big database, you can do some damage with general purpose. But if you need more power, you need to increase the instance type. Okay, that's very important to know. The pricing, we have 3. Actually, it says 3 here, but we have one that we have 2 more that you guys should research on. We have on-demand, reserved instances, spot instances. We have dedicated hosts, and we have savings plans. Savings plans is the latest addition of AWS. I think it was probably October, November, when they added these savings plans. Before, it was only on-demand, reserved instances, and spot instances, and dedicated hosts. Now, you may hear dedicated host or dedicated instance, different settings. See a host as a hotel and an instance as a room. That's what it means. With a dedicated host, you can have several instances. You can have several instances running. It's like the hotel, right? And then you have the instance, which is the room. That's the difference. That's the analogy that I want to give you for you to understand when you see in dedicated host or dedicated instance. Now, these guys are built either per second or per hour. So for the Amazon Linux and Ubuntu, only is per second. Now, any other operating system, you're going to be billed per hour. So very important. And you're going to be billed after the first 60 seconds. After that, it's per second or per hour, depending. Now, if you consume an hour, if you consume a minute and you consume 10 seconds of a minute, you're going to be charged for the entire minute, not for the 10 seconds. So you have to consider that. Now, when do we use on demand for predictable for unpredictable peaks, predictable traffic. Sorry, unpredictable. That's when you use on demand, right? So they're gonna go up in number as your demand goes up, or they're gonna go down in number as your demand goes down. Now, when there's a predictable pattern, then you use reserved instances. You can either go for 1 year or 3 years as a contract, and the more you reserved, the more you're gonna save. Very important. Now, with the spot instances, that's the cheapest of all, cheapest. You can save up to 90% of using the on-demand instances. So when you buy a spot instances, it's 90% more savings than on-demand. Very important. But what is the disadvantage of a spot instances? Spot instances is bidding on spare resources in AWS. What is the meaning of that? That you can put a price, you can purchase it for a price, and then you start using your spot instances. And if the price increases, you may lose your bid. It's like bidding in an auction, right? So if you have important information in a spot instance, you may lose all your data if someone bids higher than you. That's spot. That's why it's so cheap. Now, how do we know when you're gonna lose your spot instance? Because someone may just bid higher than you. You're gonna get a 2-minute window notice prior its termination. So you have 2 minutes to run, to do something. So you have to have some backup in place, some snapshots in place. You have to have some sort of a recovery just in case this happens. You have to keep your data with you. You cannot lose your data, okay? So with spot, you can specify the max price you're willing to pay per instance hour. While the spot price is below or equal to your max price, you pay the spot price. So if your instance is reclaimed due to an increase in the spot price above your max price, you will not be charged for the partial hour that your instance has run. So with spot, you can significantly reduce the cost of running your Hadoop or Spark clusters, increase your compute capacity and throughput without increasing your budget or both. So this is very good, but it has a disadvantage, like I said before. If someone bids higher than you, you're gonna lose your data, okay? Just you have to be ready for that. And you only have 2 minutes since the moment you get the notification. 2 minutes window, no more than that. Now, elastic compute, we have elastic load balancing, very important too. This guy, is the guy that distributes the traffic across multiple EC2 instances in multiple availability zones. So we have availability zone 1 here, and we have availability zone 2. We have the elastic load balancer that is distributing the traffic to these 3 EC2 instances in one availability zone. I'm gonna say AZ1. It's AZ is availability zone. Okay, so these 3 instances in AZ1 and distributing the traffic to these AZ instances, EC2 instances in this AZ2. Now, this is all inside your private virtual private cloud. Now, if these guys fail, these EC2 instances, Elastic Load Balancer will automatically stop sending the traffic to these AZ2 instances and then continue sending traffic to these EC2 instances in availability zone 1. Okay, that's the way it is. That's the way it works. Now, for you to be able to use the Elastic Load Balancer in both AZs, you have to enable cross-zone load balancing. Very important. Load balancer is per availability zone, right? But you can enable cross-zone balancing, and it will work with different zones, right? By default, that's not enabled. You have to enable it. Now, it supports health checks to detect unhealthy Amazon EC2 instances. When we get to more details of this, I'm gonna show you how it stops sending traffic to an EC2 instance when the EC2 instance is unhealthy. Okay, I'm gonna show you that. My God. Supports the routing and load balancing of traffic to Amazon EC2 instances, HTTP, HTTPS, secure socket layer, SSL, and TCP. Okay, those are transport protocols. Okay, and HTTP request. The S in the HTTPS, it stands for secure. It's more secure. So you're gonna have the certificate with this HTTP request. I don't know if you have noticed sometimes when you go to a page that is not HTTPS, that you see that the padlock is red. I don't know if you have noticed that when you go to a place, let's say, for example, I think it's Lulu. I think it's Lulu's probably. Lulu's, I think it's Lulu's ice cream parlor. Not sure. All right, this one is secure. You see this padlock here? Because this one is HTTPS. See here? Now you go to a website that is not secure. I don't know. I cannot think of any website that's not secure. But this is going to be red, and it's going to tell you the connection is not secure, right? This one has a valid certificate, right? And it has everything that it needs to be secure. So it means that this particular website can accept payments securely. Okay, that's very important. If you see a red padlock here, be careful. This is HTTP, and it's not secure. So don't give them any personal information, any credit card number or anything, because that's not secure, right? Health checks. This is what happens. This is the endpoint here when it says the end checks, health checks. So every 10 seconds, we expect the 200, okay. So 200, that's a status code that tells me that everything is okay. My recommendation is take a look at the status codes, in the 100s, 200s, 300s, 400s, and 500s. They will tell you the feedback that you may or may not be expecting, okay? So in this case, we're returning 200, it's okay. When we said, the elastic load balancer send the head check to this endpoint. Here, monitor that PHP here. The response that it gets is 200 if everything goes well. So this is an if statement in programming. So we're telling if this is all works, call to the database works. The disk is not full. The call to the third party works. Other dependency work, we're gonna return 200, okay. So everything is fine. Every 10 minutes, it's gonna check this. It's like a heartbeat, right? It's like a heartbeat. Else, if this is not true, then we're gonna return a 503 service unavailable. So all the status codes in the range of the 500s, it means a server-side problem. Something is wrong, okay? Something is wrong with my server. Something is not working properly. If it is in the range of the 200s, everything is okay. Everything is positive, right? Every status code has a different message, but everything in the 200s, it means that everything is okay. Everything in the 400s, very important. Everything in the 400s, it means that there's a problem in my side, in the client side. And everything in the 500s is in the server side. Very important, okay? So every time a request is sent through HTTP, you are sending a request and you are expecting a response. When you expect a response, it includes a code. The code has a message. In this case, if everything goes well, okay. If something goes wrong, the service is not available, okay? It means that the EC2 instance is not healthy. Very important. Now, when the EC2 instance is healthy, it's gonna show in the status in service. If the EC2 instance is not healthy, it's gonna show out of service, okay? You can see that in the EC2 and the load balancer configuration and details. Sticky session. What is a sticky session? A sticky session is a feature that load balancers has. Load balancer has. The sticky session feature is a load balancer enables the load balancer to bind the user session to a specific server instance. So if you want to bind one user to a specific instance, okay, because the user is using the same information all the time, you can use the sticky sessions. The only problem with sticky sessions is when you have that enabled, all the traffic is going to go to that instance, right? So if that instance is gone, we have a problem, right? With sticky sessions, you can limit your application scalability. I don't want my applications to scale up, scale down. I can limit that with the sticky sessions. You can lead to unequal load across your servers. Let's say that you want to send a specific load to one server and the remaining load to another server. You can use a sticky session. And you can affect the end user response time since a single user's load isn't even spread across servers. When you affect the end user response time with a sticky session for that user and that particular EC2 instance, it's going to be super fast because it will be cached. The information will be cached, so you can affect that response. Sometimes it's good to use sticky sessions. Sometimes it's not good. It depends on your use case, what you're using it for. Okay, that's a feature that you can enable with load balancers. Okay, so instead of using sticky sessions, you can use cache. So persistent sessions outside in distributed cache. We have the server here. We have the cache here. Cache. And what is the cache purpose? The purpose is just to store all the information here. So when people access this EC2 instance again, by the way, this is a web server, right? But an EC2 instances can be a web server. You can use, if it has port 80 is a web server because you access that EC2 instance using the browser port 80, and you can cache all the information there. If sessions are stored on nodes, session loss is a risk. But if you do it on the cache, you have more persistent data because that's outside in a distributed cache. So be careful with any questions that have to do with persistence. If you do it in the nodes, you may lose all the data, right? But if you do it in a distributed cache outside that part, then you have more persistence data, okay? And what we're looking for here is persistence, right? Because we want to keep the data. We don't want to lose it, right? So we can also, instead of using sticky sessions, we can use DynamoDB, right? When you see NoSQL database, we're talking about DynamoDB, right? That's for sure. The database that AWS has that is NoSQL is DynamoDB. That's it. Because RDS is a SQL database, right? So we have here, you can save the data in the database. That's normal because whenever, for example, when you place an order in a website, that order will be saved. Once it's processed and everything, it will be saved in the database. That's why when you go back to the website and introduce your the order number, you can retrieve that information and see your order details because that order was saved in the database in the first place. So basically, you are introducing an order number, and in the background is running a query that includes that number, and is retrieving, fetching all the information from the database and presenting it to you in the UI in front of you. That's persistent storage. So if your web servers go down, what happens with the database? It keeps the data, right? But in the other sections, if you do it in the nodes and you lose the web servers, you may lose your data which is so important for you. Finally, auto scaling. We have this guy. What does it do? It works with EC2 instances. Okay. So when you do auto scaling, you have to create right here, auto scaling groups, right? You have to create an auto scaling group. When you create an auto scaling group, first you have to create a launch configuration. And what is a launch configuration? A launch configuration is nothing else but whatever you do here, all of these guys. All of this is part of the configuration of the EC2 instance. You see, all of this is the same thing that you're gonna do here, right? Same thing, because you will, okay? You're gonna create a configuration. It's the same thing as creating an EC2 instance, right? Same thing. You're creating here an EC2 instance, and here we're creating the same thing. But we have to create a configuration because this is what the auto scaling group is going to use to create your instances. Does it make sense? It makes sense, right? So auto scaling is gonna have a template of all the instances, right? And it's gonna use that configuration to create an EC2 instance when you need more servers or less servers. So let me create this real quick. I'm gonna just go add, let me call it my first configuration. Okay, let me see my first launch configuration. All right. Storage, the same thing that we saw as we saw before in the EC2 instances. I'm gonna keep this 22 port. I'm gonna just launch the configuration. Okay. I don't need a key right now, so we do this. All right. Now, after that, automatically it prompts you to create an auto scaling group. So we can do my auto scaling. Say my ASG, my auto scaling group. So we start with one instance, right? We start with one instance. I want to start with two. Okay, two. I'm gonna choose this subnet. I'm gonna choose two subnets, probably 4 to make it more highly available, right? Here we can have some health check grace period. That's the time it takes for wait before checking an instance health status. The grace period begins when an instance comes into service. If no value is provided, a default of 300 seconds will be used. Enter 0 for no grace period. So it's up to you. Instance protection, you can protect from scaling in, just in case you want to know that. If you want to use a role, you can use a role. Okay, I don't have any role right now. I can create one. And then I'm gonna keep this group as initial size. We can have a scale between 2 and 2 instances, maybe 2 and 4, but I'm gonna keep this group as its initial size. I'm gonna see this here. I don't need a notification right now. I'm gonna configure the tags. You're gonna know how important tags are when it comes to billing and cost management, but we're not gonna put this tags right now. We're gonna review, everything is fine, then we create the auto scaling group, right? Now, when I come here to auto scaling groups, so instances is creating 2, right? You see here? They're gonna create 2. The status right now is healthy. It doesn't mean anything until this is complete. Okay? So right now we have 2 instances, desired capacity is 2, minimum capacity is 2, maximum capacity is 2. So in other words, I'm saying I don't want less than 2 or more than 2, right? That's what I want. But this is up to you. You can choose whatever you want, right? So let's wait for this. This one is already in service, right? Now, if I go to the EC2 console, I'm gonna see that one is already running, right? You see, they're already running here. Okay. Now, I have to hear what is in service. I want to, let me see here, this ending in 39E. 39E. Right here. If I stop this one, it will show out of service, right? And it would automatically create another one. So in this case, I did it manually. I stopped it. But what if it stops because it has a problem by itself? It will still work, right? This is for the sake of showing you what happens with auto scaling. I'm just did it manually, okay? So let's wait a while. Let's keep it this way. And now you see here? You see it says unhealthy, right? So it's sending a check, a health check, and it says unhealthy, right? Now, in a few seconds, I don't know exactly how long it takes, but in a few seconds, well, actually, I set it up for 300 seconds. But that's between health checks. In a few seconds, it will create another one for me and adjust to this capacity that I selected, right? So we see how available it is with this auto scaling feature, that when one server goes down, it will create another one to keep the demand, to keep the demand. So if we continue, refreshing here, it deleted one, and in a few minutes, it should adjust to the new capacity, right? Okay, I'm gonna go back to this later. In the meantime, let me finish this. So we have here the base configuration, auto scaling group. Auto scaling group, it has one, you create scaling out, right? With what I said, scaling out is increase the number of EC2 instances. So we are creating 3, we had 2, but we need one more. And here, scaling in, we need one less. So the same one, not the same one, because it goes by the oldest configuration. That's how auto scaling knows which one to remove. It's just by going by the oldest configuration, right? The one that was the oldest one. That's the one that it will remove first. So if you come here, there you go. You see? I have 2 again. You see, guys?
Yes.
Okay. So I remove one, I stop one, and then it just adjusted to this capacity, deregister the other one, and created a new one. You see? That's how auto scaling works. So by using auto scaling, you will never be you will never be, deficient. You will always have instances to keep with the demand, okay? Auto scaling, maximum capacity, desired capacity, minimum capacity. You can have schedule scaling by using CloudWatch, okay? We can use CloudWatch for that. We're gonna see that later in the course. And you can have dynamic scaling, based on demand, depending on the CPU usage of your resources, and then you can scale up scaling, depending, okay? So, knowledge check. We spoke about traditional monolithic architectures are hard to scale because, they're all uniform. They're not microservices. We talked about reserved instances that are unused. EC2 capacity, the price you pay is determined by the supply and demand of the instances. That's not true. That's why we have an X that is red. That's not true, right? Reserved instances are use capacity, and the price you pay is determined by supply and demand of the instances. No, because they are not the on-demand EC2 instances. the price depends on what you buy, right? You buy for a year or 2 years, depend on the whatever predictable patterns you have, right? With auto scaling, you can specify this desired capacity, which ensures that your group has this many instances. That's true, because with the auto scaling, we set what? What do we set? The maximum, desired, and minimum capacity. So that's true. AWS recommends replicating across AZs for resiliency. That's true. Highly available, 2 or more availability zones for resiliency. Very important. One benefit of AWS cloud computing is to stop guessing capacity. That is true. We saw it in the 6 benefits of the AWS cloud. The sticky sessions help to increase your application scalability. That's not correct, because when you use the sticky sessions, you limit the scalability of the application. Okay? So guys, do you have any questions? This is a lot of talking for me, but it's only 3 hours. It's not 6 hours or 8 hours a day. I wish I could. My classes always are interactive when I ask the students questions and everything. But as it is only 3 hours and there's so much content to cover, I don't have time to ask questions so frequently. So I ask you to bear with me and watch this lessons and try to just do the quizzes and watch the videos that I schedule for you to watch, and keep up with the assignments, because that's very important to pass this exam. I assure you that if you follow my recommendations and practice with exams that I'm going to provide for you, I'm going to provide exams for you from the 2 different platforms for you to practice and practice and practice, because unfortunately, based on my experience, what gives you the best practice and the best tricks to overcome on exams is practice exams. That's what gives you that, okay? More than anything, right? So 2 components. Go over whatever we see in class, and also when we get to that point, do exams 1 and 2 times and over again to become masters of that particular content, okay? Do you have any questions? That's enough of talking for me. I think.
Are we going to have white papers where we can learn from, like a book or something?
You should receive that after the class. You should receive that. After we finish, you're going to get a bunch of emails from me. So you guys you're going to be overwhelmed with emails, probably 5 or 6 emails per class. And I'm going to tell you what to do in every email, okay? And one of them is the white papers, right? So let me do something here before we go. So these are the exams that AWS has, okay? I have this 4 and this one, okay? I wanted to get this one, which is easier than this one. So if I got this one, this is easier, but I don't have time for that because I have these classes and I have like my computer science masters. I don't have time for this. And I wanted to get some of these specialties here, which are very, on demand right now. People are looking for experts in advanced networking and security. If you get to have these guys, my God, for these students that we're talking to, they are doing some security plus and all that. If you get these guys, let me tell you something, you're gonna get a job right away, and your salary is gonna increase drastically if you get one of these guys. Yeah.
Professor, is this the solution architects helpful for the data analytics specialty?
For that one, I think that this one has to do with that, but more than this one, probably these 2 guys here. and the professional level.
Okay, so that will be after this one.
Yeah.
Right?
But don't worry, if you read this, if you guys read this, 1 year of experience solving problems and implementing solutions using the AWS, that's not entirely true. Why? Because I didn't have this. I didn't have this. And I have all these 5 certifications with no 2 years of experience in an AWS. I have experience as a programmer, but in a native cloud environment where is only AWS, no. I worked in a hybrid environment where they use AWS, DynamoDB and all RDSs and S3 and all load balancers, all that, but it is not completely and entirely AWS, okay? So this is not, don't forget about this. This doesn't exist, right? Based on my own experience. If I did it, you can do it too. This doesn't exist, right? So don't feel panic. Even this one, you don't need any experience, any knowledge for this one, for the foundational. Nothing. You just need to take my class. That's it. Nothing else. Okay, this is the one that we need. Okay, so we're gonna get the, okay, very important. I wanna tell you this. We're aiming at taking the exam a few days after we finish the course. Why? You see this here? SAAC02? You see it here?
Yes.
Yes.
You see it? Okay. This exam, which is the one that it is currently in place, will expire on July 1st. So it means that this is going to change. Okay? Now, right now, AWS Academy doesn't have a curriculum for the SAACTCO2. It covers everything. I mean, this class covers everything for this exam, right? It covers everything for this exam. But this is the one that I have, and this is the one that I know of, because this is new. This is gonna be in effective on July 1st. This one is gonna expire that day. So I strongly recommend taking the exam before July 1st, okay? If you want to play safe. Now, fortunately, the platform that I'm going to provide for you guys has exams that cover both the CO1 and CO2, okay? So if you take those exams, practice exams, you're gonna be ready for both of the exams. But I would like to play safe. If you can take it before July 1st, I'm gonna be more confident about you guys, and I can assure you that you have a high percentage of passing the exam, right? This one will expire on July 1st. This one is effective on July 1st. They say that what they call is retiring. This one will retire on July 1st, right? Now, okay. Now, it's basically the same. They only change the domains. Let me see if I can have this guy here. Let me see. This is 0101. Wait. This is 02. So I'm gonna do this, and I want to minimize this, and then one moment. Okay, so I want to close this guy. I don't need this guy anymore. So I'm gonna have this guy here. I want to minimize it, and then I'm gonna put this in the left side of my screen, and this one on my right side. Okay, so I can compare them side by side. So we have here the CO1 and CO2, right? If you take a look at this section here, it's almost the same, right? 1 year of hands-on experience, 1 year. Let me make it a little bit bigger for you guys to see here, and a little bit bigger here as well. So basically the same exam content. So who was the one that asked about the white papers?
Me,
What's your name?
Olivera.
Olivera. There you go. I'm gonna paste it here in the Slack channel. I recommend get it in right now, because when the meeting ends, you will lose all this, right? So that's the PDF file that you can guys get. Okay, so this is the white papers that you can use. I'm going to Slack all these guys too as well. Why not? I'm gonna Slack him when I finish the class, okay? So exam content is gonna be multiple choice, multiple response. So you may have 5 options and you have to answer 2. If one is wrong, everything is wrong. It's everything or nothing, okay? It's not that I failed 1 and I did 2 correct, I get 2 points. No. It's everything or nothing, okay? With AWS, there's no partial points. Multiple choice is there are a lot of distractors, right? The 3 incorrect responses and 1 correct, right? So but basically this is traditional. You have 4 possible answers and 2 are incorrect, 1 seems correct, and 1 is correct. So that's the way it is all the time. So you have to read carefully, because you have to watch for keywords. That's very important, okay? Keywords. So basically everything is the same except the domains. You see the domains here? You see the domains? So before in CO1, the domain was, the first one was design resilient architectures. Right now is design resilient architecture. Number 2 is define performant architectures. Number 2 is design high performing architectures. Number 3 is specify secure application architectures. Number 3 is design secure application architectures. And number 4, design cost optimized architecture, design cost. You see, this guy is not in the exam anymore, right? So it may seem that it's easier. It may, but you have a different percentage here, right? So it balances out all the percentage here in a way that what was less before, it may be higher now. This one was 10% before of the exam. Right now it's 18%, okay? So that's basically the difference between one exam and the other. We have one less domain, right? And the percentage is distributed differently among the domains, okay? But it's basically the same. If I were you, I would study as much as possible. You have 2 months. 2 months is enough to study for an exam. You have 2 months, right? Study as much as possible. Watch every video that I assign. Read all the white paper one at a time, not everything. You have 2 months. And when we get to the exam part, when we give you an exam every single day, and you have a platform where you can repeatedly practice the exams, and we're gonna do exams in as a group in class, where everybody's going to contribute to the answer. When you would do all that, I think that 2 months is enough, okay? It took me less than a month to get the certification of the professional one, the DevOps. This one. It took me 1 month, or maybe less than 1 month for this one. So guys, you can get this one in 2 months, for sure, okay? Look at this one, 2 years of experience. I don't have that, and I got it. 1 year of experience, you may not have that, but still you will get it. You just have to put in the time and the effort, and for sure, I can guarantee you, you will pass the exam. if you study properly. Okay, that's very important. Properly. Okay, so guys, sorry to take more time than usual. It's the first day. We lost some time with the introductions and all that, but tomorrow is gonna be from 1 to 4, and I try to cover as much as possible so we don't have to go over the 3 hours, and also respect your break. Okay, so if you have any questions, tell me now before we go. And then I wish you a good day, rest of the day.
We're gonna be receiving the emails with the videos for us to watch for this and the exercises.
I think that they are scheduled to be sent to you guys at 5 p.m.
Okay. And you're gonna paste in you're gonna share with us on Slack the links for the white papers and all that?
Right, right.
Okay, perfect. Thank you.
I think I did already for the white papers. What I'm going to Slack is the differences between the two exams. Okay, but I think I did it here.
It's not there.
It's not there?
Mhm.
Really? What happened? It's right here. Is it here? It's right here. You see it?
Where in the Slack? I have not seen.
Oh, sorry. Oh. Sorry. It says for, okay. Right here. Wait, one moment. All right, this one. White papers, right?
Mhm.
Okay.
I just have one question, Professor. How soon would this video be uploaded to YouTube? Because I kind of missed since 4 o'clock. I had a work meeting, so I missed everything.
I have to change the strategy because I'm recording the entire class, which is not good because it's a heavy file. What I have to do is record the first part when we go to the break, and I didn't realize that I was recording the break too, and stop the recording, and then continue recording after the break.
Okay.
I will try to upload this